This is review problem number 1 from assessment number 4. We're going to find the determinant in this problem. And the reason we want to find the determinant is, the whole goal is to determine whether or not this matrix has an inverse. So that's the goal behind this problem is, does this matrix have an inverse? Now to find a determinant of a 3 by 3, we should already know how to find the determinant of a 2 by 2. And the goal with finding the determinant of a 3 by 3 is, can we break it down into some steps using determinants that are determinants of 2 by 2s. Here's how we break it down. We start with this top row, and you'll see I have it circled already, but we start with the top numbers 6, 5, and -3. And we're going to use these top numbers to basically cancel out rows and columns. Now the process we have here, we're going to end up with 3 different determinants. We're going to end up with a plus, minus, plus type of multiplication and addition as we go through this. So plus, minus, plus, keep that in your mind as we go through this. So we're going to start with this 6, and 6 is the top left corner, which is the first column and first row. And we're going to say that we're going to take the 6 and we're going to multiply it times some determinant. Now how do we get that determinant? Well, we get the determinant from crossing out the first column and the first row, because that's where the 6 was located, and then looking at the 2 by 2 matrix that's left. So we take 6 times the determinant of 4, -2, -4, 5. Now this plus sign here tells us that whatever this number was at the beginning in the top left, we just want to leave it the same. Just basically multiply it times a plus, which is not going to change the sign. But this middle term that we're about to use, we want to basically change the sign. We want to subtract it. So if it's a negative, it's going to become a positive, and so on and so forth. So we look at the middle number. The middle number is 5. And the middle number is the top row and the middle column. So we're going to subtract 5, and we're going to cross out its column and its row that it's in. And that leaves us with a 2 by 2 matrix that we can find the determinant of, which is -5, -2, and 1, 5. And then we're going to go to the third part, and again the plus sign just tells us to leave the sign. So then in this case is a negative sign, we're just going to leave it. So it's -3 times its determinant. This is the third column and first row again, or third column, first row, and we're going to do times determinant of -5, 4, and 1, -4. Now once we have this written out, it's actually pretty straightforward to find this determinant. We start by finding the determinant of these smaller matrices. So this 3 by 3 has been broken down into these basically 3 determinants with the multiplications for the top row. So we're going to find the determinant of the first 2 by 2 by taking 4 times 5, which is 20. And we're going to subtract out -2 times -4, which is 8. And we got to make sure we multiply that times 6. And then we're going to say subtract 5, and then we're going to do -5 times 5, which is our -25, minus -2 times 1, which is -2. Minus 3, and then we're going to say times -5 times -4, which is 20, minus 4 times 1, which is 4. Subtract these, we get 12. So 6 times 12 minus 5, and this will be a plus 2, so -25 plus 2 is -23, minus 3, and this will be 20 minus 4, which is 16. 6 times 12 gives us our 72. 5 times 23, that's 115, and that'll be positive, so plus 115. And then 3 times 16, 30, 48, so minus 48. Let's go ahead and add these together. 115 and 72 would be 187. So we end up with 187 minus 48. Subtract 40, That's 147. Subtract 8 more, that's 139. So our determinant's 139. Now what does that mean? Because this determinant is not equal to 0, that means A has an inverse. And I'm using A to illustrate that this matrix that we started with has an inverse. So you could say A inversed exists. And again, we figure that out by if this number is 0, A inverse does not exist. If this number is any other number other than 0, it exists.